All right, everyone. Welcome to this week's presentation from DBA Fundamentals. As always, I am Kevin Wilkie. So this presentation is called LocalStack for Snowflake with Waldemar Hummer. Today is August 20th, 2024. We're going to show all kinds of goodness that happens with the LocalStack for Snowflake and how you can use it to make your life hopefully easier. On the upper right-hand corner of the screen, hopefully you see the names of the three leaders of the DBA Fundamentals group, Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. To the right of our names is one of the easier ways to get hold of us on Twitter, or X, whatever we want to call it these days. So below that is our social media places. You can actually find us in various ways. The easiest, probably the one that most, if not all of y'all actually came through Meetup. And on there you'll find all of our next future presentations. Below that is our actual website, dbafund.com, where you can find all of our past presentations, links to them, and all of our future presentations that will be coming down the pike. Below that is our YouTube site. So it's dbafundtube.com. It gets you a direct link to our YouTube site, where you can remember to like and subscribe, and you can see the presentations whenever they're actually published to the web, and you can view all of our past presentations as well. Be sure to actually go out there and click on the like and subscribe button today, just to make sure you actually know when today's presentation is available for use. Below that is our Twitter handle for DBA Fund itself, DBA Fund, and our Slack channel and our LinkedIn group. Some of our upcoming conferences that I'm sure y'all want to be a part of, if not already been thrown out there to them. On the right is the European Microsoft Fabric Community Conference, which should be lots of fun about Fabric and whatnot, which I know everyone has seen lots of stuff and will learn more about. On the left is one of the ones that I'm surely happy about, is the PASS 2024 Data Communities Summit. Huge. If you haven't heard of it, be sure to go to it. Find a way to talk your boss into letting you go to it, pay for it, make it all good, because that is a place where you will learn all kinds of stuff. Snowflake, SQL Server, Fabric, Power BI, you name it. If Microsoft touches it in any way, shape, or form, it's going to be there. And some things Microsoft doesn't touch too, which is always fun to learn about. Please be sure to remember to turn off your video and mute yourself so that we can all focus on Waldemar. And please type any questions you have into the chat, which I'll be feeding him throughout this presentation. And actually, when you feed in questions, if I don't know, can answer, I will throw it over to Waldemar and he can answer right away. And here's a quick little bio of Waldemar. And so with that, Waldemar, over to you, buddy.
Wonderful. Thanks so much, Kevin, for setting the stage. Yeah, thanks so much for having me and giving me the opportunity to talk a bit about LocalStack and what we're doing with our brand new Snowflake emulator. So let me just go ahead and share my screen here. I usually love to do these presentations or meetups in a kind of an interactive way. So please feel free to interrupt or write any message in chat at any point in time. I'm also going to be walking through a couple of live demos. It's always, from my perspective, great to try and show something running, see some actual data, see some application running, and hopefully the demo spirits will be with us today. But I definitely want to make sure that this is a bit interactive and also interesting for you to follow along. So let me just start the slideshow here. Okay, so after this short intro, and thanks again for setting the stage here, just a brief overview of the story and what LocalStack generally even is. So LocalStack is a cloud development platform that is actually originally coming out of the AWS space. So it has a pretty long history as an open source project, starting back in 2016, actually, when we had the first commit of LocalStack in a public GitHub repository, and it was kind of growing over the years, really as a side project initially, and then 3 years ago we actually started building a company around this. Had a couple of major releases in between in the meantime, and by now a globally distributed team of more than 50 team members and continue to grow. And we've been focusing a lot on AWS in the past, also some data platform emulators, but mostly also serverless apps. And we've recently started to become more broad, especially in the data ecosystem, and started building a first version of a Snowflake emulator. And that's what I would like to briefly showcase here today and walk you through. Again, our story, I think we're very much branded in the open source. A lot of what we do is available in some public GitHub repositories. You can find those if you're interested and check it out. And maybe you even have some AWS use cases where it could also be beneficial for you. But for the session today, we're going to be focusing mostly on Snowflake itself. As a general background, why we even exist as a project and as a company, and again, a lot of that applies maybe to the AWS and cloud space initially, but increasingly also to the data space, is that we're seeing a lot of challenges with cloud development these days. So obviously, the fact that the cloud is a remote system, there is these relatively slow feedback loops of having to deploy every change to the cloud, waiting for something to happen or deploy. Oftentimes it works via some tools like, I don't know, maybe Terraform if you're using some infrastructure as code or something like that. And it basically just deploys these changes, maybe running a few tests, something's not working, and then sort of having to update again. So kind of slow loops of testing and deployment. The other point that's challenging for teams is remote debuggability. So one of the use cases we see a lot, for example, is having things like CI pipelines where tests are running. I think there might also be some cases with actual data tests and data pipelines running. And if one of them is failing, it's really hard to get like the context, and you have to scrape through the log files or what's actually going on there in the remote system. And then also finally, when it comes to just managing different dev environments, it can be challenging and also costly to make sure that things are cleaned up properly in these dev environments, and there's a lot of automation that needs to go into just managing different infra. And again, as mentioned, AWS is really our initial use case, but we see an opportunity here to venture into other ecosystems, including Snowflake as well. So I guess that probably in this audience, I don't need to explain too much about Snowflake itself, but it's obviously a cloud data platform that allows for the scalable data processing flows. So things like uploading data files in different formats to stages, running SQL statements over them to create databases, tables, views, and so on. Then being able to select data from different files and tables, running scheduled jobs for ETL pipelines and so on and so forth. So a lot of like a very comprehensive platform that takes care of all these different aspects. And there's a lot of native integrations and tools out there that you can use to interact with the platform, starting from Python, Pandas data frames, for example, or Snowpark or JDBC driver and so on. So a pretty broad and vast ecosystem of integrations already. And there's also there's certain similarities to some other big data services in AWS. So Athena or Redshift are trying to achieve a similar or have a similar value proposition, right? So you just give us all your data, and we can provide the insights and queries for you. Basically, a managed version of these big data query services is what Snowflake provides. And again, if you have any feedback or questions, please feel free to drop in the chat if you have other definitions or anything that I'm missing here in the explanation of Snowflake as well. So one of the things that we have been learning in our interactions with existing users and customers of the AWS emulator that we provide with LocalStack is a couple of questions were coming up. Is it possible to also develop our data pipelines locally, right? So is there a way to have some kind of an emulated or simulated environment locally that I can use for local testing? Something that came up a few times in some Stack Overflow forums or Snowflake forums directly actually as well. And currently that's not something that is supported, and given that we are we have been operating in the emulator space for quite some time, we have sort of set out this challenge to start with the first version, the first implementation of Snowflake to try and address this use case and really see if it's actually feasible and possible. So a lot of that is also exploration and breaking the sort of new grounds and of what's possible here. And we'll we'll soon get to some live demo to kind of showcase what it looks like and what's currently provided in terms of features. But essentially, what we do is it's an emulation on the Snowflake API level. So what that means is that we can speak the same sort of API responses and requests as the real Snowflake service. That means that usually your tools natively integrate also nicely with the emulator, right? So it's just a matter of pointing it to a local endpoint, and then you can use the same kind of functionality like a JDBC driver, for example, or dbeaver or any other visualization tool. And for the most part, it just usually works out of the box, obviously with some rough edges still initially in this early implementation, but it's really meant to be an easy drop-in replacement for testing purposes, right? So it's not obviously any production system. It's really just for quick experimentation and testing. One of the other things that we see a lot on LocalStack in general is once you have a setup that works locally and you can run your tests and maybe data transformations or certain data quality checks and so on, it's also easy to translate that into a CI environment, right? Let's assume there's some kind of a automated CI/CD process. Transferring that setup from local into the remote environment is essentially just flipping a switch and making it work in something like a GitHub Actions or some other system that runs these CI runs. And I'm again very curious to hear also maybe the feedback from the audience, whether that's something that's currently already established in the industry when it comes to just automating these data pipeline testing and so on. So just to go through some of the features that are currently provided in this in our first early version, and just to do also a bit of experimentation management. So we're currently in a public preview phase. So this is a product that's not currently fully GA, so it's not generally available yet. But we're really sort of working with early adopters to prove out the value, finding out about use cases. Is that something that's helpful and useful for folks out there? But this is some of the early feature set that we've been working on. So you can do some basic operations on warehouses, creating databases, schemas, tables, and so on. So just using the regular data manipulation and data definition languages. Then there's support for stages. So just uploading files like an S3 or a JSON file, for example, which can then be used to query data from it. That's quite nice because we can use our existing S3 implementation in the AWS LocalStack implementation. So it nicely integrates with some of our existing tooling. Then there's things like Snowpark or SnowPipe streaming, which is also supported in the first version. You can run UDFs, user-defined functions, in JavaScript and Python. We don't support any of the other runtimes just yet. It's just these two initially. Oops, it was wrong. Yep. Then there's things like tasks for scheduled execution, table streams, and a few other things that we'll see also in the demo in just a couple of minutes. So that's an initial set, and we're, I would say, more opportunistically exploring whatever users are really asking for and kind of working on new features as they come in as feature requests, essentially. But that's what we have so far at this point. Right, so this is just a short video, and again, we'll just look at that also in live in just a minute. But what you'll see here on the left-hand side basically is the LocalStack container running in a terminal, and on the right-hand side we see a dbeaver instance, and it's basically just running these queries to create some tables, insert some data, run some select statements, and so on. But I think we can also step through that live, so we don't need to go through this entire video now. But you can see that it's basically gives you these instantaneous responses to the queries that are running from the visualization tool. Okay, so yeah, I guess with that, as I mentioned, love to do this interactively as much as we can and dive into some demos. And feel free to chime in at any point in time if you're interested how things work or if you want to dive into a specific topic in more detail. But the general setup, how we can start the Snowflake emulator is we've provided so LocalStack in general runs in Docker. So Docker is our platform for shipping the software. You can download a Docker image and then run it locally as a container on your local machine. and then interact with the system. And we're providing this image. It's called LocalStack/Snowflake, and then we can use our LocalStack CLI to start up this container, and it just needs an auth token configured, which I've already done in my environment. So I'll just go over to my terminal here, clear out any previous sessions, and I'm just running this command now, which is what we just saw. So the image name is LocalStack Snowflake, and then we say LocalStack start, and I'm just adding some debug trace flags here, so we see some additional trace output, which is more detailed. So now it's basically starting up, and what I can do now is I can do a Docker PS, and we actually see that this container is now up and running, and it's using a canonical port here that we use. It's port 4566 that can be used to interact with the system and run queries against it now. So now this is up and running and ready, and now we can actually switch over to my dbeaver here, and this is, I believe, actually the first demo here. Demo 1, just basic queries. So let's just step through some basic queries to create some tables, insert some data, and interact with this emulator here. So I have this prepared here in my dbeaver. I'm just literally gonna step through this. Let's maybe do the side-by-side view. So I'll add the terminal so you can see that in the background, and then step through these commands. And what you'll see is in the background here, as the output changes, we are actually issuing these API calls, and it's returning the results. So we just do a select from the table after inserting 2 items. So we get Bob and Alice back. Then I can create this function here, a UDF that is written in as JavaScript in this case. And then we can say, I want to call this function by doing a select func1 with the parameter world, and the result is hello world. So this is kind of the most simple interaction that we can have with the system. And maybe we can briefly take a look at the connection information here. So the way this is configured here is we just set a connection string with the host as this just happens to be snowflake.localhost localstack.cloud. That's a special domain name that we use for that points to basically a local IP address. This is the port 4566 that we've seen before, and then database test, which is just the default database, and username and password, which at this point is just test and test as well. So yeah, so as you can see, same look and feel as you would do against the real Snowflake instance, but all the interactions are basically happening against this container that's running on my local machine here. Okay, and again, I'm hoping that maybe some questions will come through, but I'll just continue in the flow and show a few more demos that are maybe worth highlighting, and just showcasing the general capabilities of the system. So what we've done, in fact, is we've looked at some of the Snowflake sample apps that are provided as quick start samples. One of them is a sample around some COVID vaccine data set. I think that's fairly commonly used in the industry for showcasing different features of data platforms. So just go here real quick. This is actually the original source of this sample app. Usually they have also a GitHub repository associated with the code, and we just took that some of that code and just try to run it against LocalStack directly, the emulator. So this is actually a repository we've created. It's LocalStack samples / LocalStack Snowflake samples, and this is a selection of some of the first sample apps that we've created here to just showcase different kind of features, and we'll actually go through some of those in the demo as well. And the one that we're now looking at is this COVID data set. And I'd just like to briefly step through what that looks like. So that's a data set that contains various different data points for mobility data of different people, then vaccination data per state or per geographic region. And we can now basically ingest some of that data, put it into a CSV file that is going to be stored in a local S3 stage. We can then load the CSV file into a table and then run some simple select queries over that table directly. And again, I'm gonna do this directly from my dbeaver instance here. So I'm stepping over here into my sample 2, which you can see here. And now we're gonna, again, just basically run through the steps. We're first creating a stage. So stage is really this concept of something where you can put some data and interact with it. And then we're running, I have already downloaded this vaccine CSV file. Let's maybe take a look at that real quick. So if we go here and I look at this TMP file, so you can see jurisdiction, week of allocation, dose allocations, and so on. And you can see sort of the information for different states, jurisdictions, dates, and allocations of the doses. So that's one particular part of this data set, which we can now use here. And we can, now we can actually just go ahead and say, I want to put this file into the stage, right? So you can reference the stage with S1, put it into some test folder. We can then create a table with the corresponding schema, right? So just going to create that table. We can then issue a copy into command. So we just copy into this COVID-19 table from the stage with a certain file format. It's going to run this file here. And now the table has been created and we can actually start querying from it, right? So we just do a select statement here. It's giving us back the data with the basically what we just saw before in the CSV file as well. And I think there's some other slightly more interesting query that I've also copied from the Snowflake sample app, which gives us the jurisdiction with the sum of allocations grouped by the jurisdiction ordered by vaccinations descending, right? So we can see, for example, California has the highest number of vaccinations, unsurprisingly. So, right. So again, relatively simple example, but it kind of showcases, again, you can use a file, a stage to upload your data in some format like CSV or JSON, create a table, and then just experiment with it and iterate very quickly on the logic without essentially having to be connected to the real system, right? So everything we do here is really for quick experimentation. In fact, by default, LocalStack is also an ephemeral system, so there is no built-in persistence per se. We do have the persistence mode also, which I'll showcase in a few minutes. But if I basically go ahead and restart the container here, so if we just restart the LocalStack Snowflake container, then we basically have a fresh state. And if I run, for example, a select here from that table that we created before, it's going to give me an error and say that table doesn't exist. So we literally have to step through these individual points here again, and that's sort of by design, and because that's what we usually give users, just a fresh instance every time they use the container. But we also have a persistence mode, which I'll get to in a few minutes as well. Okay, so that was the stage concept, and this, again, simple queries over this data set here. More to really showcase how easy it is to take existing sample apps and just run them on the system. Okay, so I have a couple more demos, and literally I'm just going to walk through some of them, and hopefully they will contain some interesting details for you. Please feel free to chime in with any feedback you may have. The next one we looked into was a city bike trips application. So this is something, again, came out of one of these getting started guides. This one actually comes with a small web user interface as well that connects to the API endpoint and then runs a bunch of queries to analyze the usage of city bike in New York City. This is also an interesting case here because the data for this sample is available in a public S3 bucket, so one that AWS, or that is stored in AWS but has open access permissions. So you can, anyone can list the contents and download these files. And this is what we've integrated here into the emulator, is that you can actually directly access these public public files in this public bucket, and they don't need to exist in the local emulator per se. And we'll just see in a second what that looks like. So again, stepping over to the sample app here, maybe it's also worthwhile taking a quick look at what these samples actually entail and what they look like. So I'm switching over to my IDE here. Just opening up the right part. There's a lot of different different projects in here. Right, so this is the city bike data app. I'm just looking at some of the components of this here. As I mentioned, it has a small application server that's just hosting like some basic APIs. So you can, for example, get the monthly trips or the trips by day of week and the temperature. So these are just some API endpoints that the web UI can call. And then we have our the index HTML, which has the actual sort of entry point for the web UI, which we'll see in just a second. And yeah, so most of this is actually really defined in the sample application. Here we can see the connection details, so how the Snowflake connection is being created, and I believe somewhere in config.js, this is where we actually define the connection string with the endpoint that we saw before, Snowflake localhost LocalStack.cloud, and some test credentials for accessing it. Bear in mind, this is actually a private key, but it's a generated one, so this is not a secret key. This can be shared publicly. Essentially, this is just to authorize any client that connects to a Snowflake system needs to have one of these RSA private keys, but we don't restrict sort of in the emulator what kind of key you have. It could be any arbitrary key in fact, at this point. So we don't have strong sort of role-based access control or anything like that built in just yet. So this is really just to get the sample running here. Okay, so why don't we head over and just run this app? And again, one of the interesting things here, just go to the right directory. This would be in directories city bike app. Okay, so usually we have a make target here, which we can use to run. So there's a make seed command which we can do as the first step. So seed now basically runs through a couple of steps to create a stage, created a trips table. So trips is basically where all the city bike trips are going to get stored, and then it copies into trips. And this is now an interesting part. Okay, I'm seeing some interesting. This is probably the demo effect, but I'll have to just quickly double check that. So I believe this is what yeah, I think we need to slightly adjust that. Need to remove that Docker flags for now. Because what I mentioned before is that we have a mechanism for essentially allowing access to real S3 buckets in the emulator. And here we have this configuration variable, which is called DNS name patterns to resolve upstream, and with this particular S3 bucket name. So this tells the system, please don't use this as a local bucket name, but use the actual remote system for fetching that data. So we just set this configuration here, and I can then restart LocalStack here without this setting. Okay. So I'm just starting it up again, and we can then run our seed one more time. So again, the seed command just creates a stage against this S3 bucket. It now populates the data from these 3 buckets, and it's literally downloading the file on the fly from this remote bucket, inserts it into the table, and I think now everything has been inserted. There's also some weather data that's created here. Okay, and then there's a second command, which is make web start. I think that's the one. Okay, so there's something else. Cannot find module express. Am I running the right? It is web start, right? npm start. Let's just do another npm install here, just in case. Maybe I'm just missing some dependencies. Okay, right. So it's just missing the Express library, and then we can go to localhost 3000, which gives us this web user interface, and it's already loading the data here. And as you can see, it's basically just showing some information like monthly distribution of city bike trips, how many of them were done in a certain period of time, weekly distribution or weekday distribution. Interestingly, less on the weekend, which is I find interesting. But yeah, there's a lot of commuters probably using these city bikes. So yeah, and again, if we look at the network console here, this is really just accessing our local endpoint. In fact, if we just refresh the browser here, it's accessing some monthly data, which gives a response back, and the day of week endpoint. And both of these are actually hitting this API endpoint here, and that calls the local emulator in Snowflake to get all this data together. So again, showcasing another sample app here, which I think is also nice because it has a UI component. And with this interesting aspect of being able to access an existing S3 bucket that's remote, and we didn't have to copy the data first into a local environment. It literally just fetches it on demand from the remote system, and then is up and running in a couple of seconds. All right, so I guess that was my demo number 3, and I'm still, maybe if there's any feedback, please feel free to chime in. Any questions around how this works, or if you'd like to deep dive in any particular part of this. But if there's
so Waldemar, I do have a question.
Mhm.
Is this only available for S3 buckets, or can it be from Azure or from a local system?
Yeah, that's a great point. So any S3 compatible API, I believe, should be supported. So it can be even like something like a MinIO, which is another S3 emulator, or obviously AWS S3. Azure, we haven't fully tested yet, but I believe there should be some equivalent in Azure as well that we can use. But it's not something we've fully tested yet. Yeah.
Awesome, thanks.
Yeah, thanks for the question there. But I think it's generally a good observation that these, especially what we're seeing in Snowflake, is creating more and more integrations with all the other clouds, right? So there's all sorts of integrations from the ingest side, or just fetching data, or even like outbound. And we'll see a bit more about that in demo as well. It's one of the pieces that's also exciting for us to make different, or create different integrations with other cloud APIs and services. All right, cool. So the other thing I want to briefly showcase is, because I think it's like an interesting feature, is table streams. Something that some of you may be familiar with. Essentially, the concept of creating these change data capture tables, essentially for Snowflake tables, and then being able to copy any changes into, like, from a source into a target table. So Snowflake has this concept of a stream, and a stream is really like if you have some kind of source table, and this might be a bit hard to read on your end. I'm just going to zoom in a little bit. So if there's some kind of a source table with, let's say, 2 columns, an apple and the value 5, then sort of each operation, like an insert, for example, creates a stream entry in a stream table, which says, there was an insert taking place. It's not an update, so update is false, and then also some row IDs, which are some synthetic IDs that get added for each of these operations. And then there's different logic for deletions and updates. So essentially, I think an update is a combination of a delete and another insert on the same ID. So it's basically a way to capture monitor any changes on a table, and then also consume these changes and copy them or pump them into a new table, basically a target table. And that is something that we've also built in a first version, because that's been often requested features by some users out there. And again, I have a small example that we can just step through here now, which in our case here, we're gonna use gym members. So this is a gym membership table. Pretty simple with ID, name, and a fee, basically how much these members are paying for the membership. And let's just go through and step through these queries here. So basically what we want to do is we want to, from this members table, create a table stream that records all the changes, and then we want to consume them into a target table to create a copy of the original members table. So we created the source table. We then say create stream member stream. So that has been created. We then insert a bunch of values into the members table, right? Just 5 entries here with some dummy data essentially. We can then do a select from the source. Actually, this is a select from the stream. So we now already see the entries in the stream table, right? So we see, for example, the insert that was happening for Joe, Jane, George, and everything, and also these synthetic row IDs here, this metadata, which is then later used for creating the copy and moving the records to the target. And now we are creating this target, this members copy table, which has the same schema and just a different name, members copy. And now that we have both the source and the stream table and the target table defined, we can actually run an insert query. So we can insert into the members copy table by selecting from the stream table where all the action is equals insert, right? So we basically I think terminology, we're consuming these stream records now and copy them into the members copy table. And now we can do a select from members copy, right? So all the entries have now been copied over. And the key part here is now that we've consumed all the entries with this statement above here, the stream table should actually be empty. So if you do another select on the member stream, there is no current records in there because the state is fully replicated at this point, right? And once we start adding new items, this will populate the stream table again. So again, something that might be familiar, to some of you, and you might have been working with this, but it's something that we heard again from various conversations that it's sometimes easy if you can test this kind of functionality and just iterate quickly on it in your local environment, and then just once you basically have the functionality ready, you push it up to the real system, and then there the full load can actually start with some proper data, right? A lot of what we do here is obviously with like a smaller subset, maybe some synthetic smaller data sets, and then sort of once the logic generally works, then the logic can be transferred into the real system, real cloud, where you have all the processing power and like the full scalability of the real system. Okay, so that was the my fourth demo on table streams. Again, if there's any questions from anyone, you can also take them towards the end. But I think it's just a nice feature that showcases how Snowflake also makes it easier to do some of these tasks like CDC, for example, or just actually manage tasks is another very interesting feature that Snowflake provides. And we also in the emulator, where you can run certain queries on a schedule. And this is what we see also a lot of times is like a combination of table streams and a task that maybe runs on a schedule and then just dumps data from one source table to the target. So that's a very convenient way, a managed way to run your data pipelines, essentially.
Do you see more places using this to help their DevOps people get up to speed with Snowflake and how it works, or even trying things out?
Yes, absolutely. So this is one of the key things, sort of that's one of the key enablers of LocalStack is really trying something out quickly without needing access to the real system, just getting up to speed, connecting some things, running some experiments. So I think that is one class of use cases where there's this experimentation, getting up to speed, and then sort of once you use it in a more established setting, like an actual maybe data pipeline and has some testing and data quality checks enabled as well. That's sort of the second class of use cases. But certainly there's just this learning aspect of experimenting with the system without needing access, without needing credentials, asking somebody for permission and so on. That is definitely one of the use cases there.
Awesome, especially since it is so much cheaper to do it, all of your testing on this than it would be on Snowflake.
Right. That's definitely one of the nice side effects in that sense. We tend to believe it's maybe not the main. I mean, it is definitely one of the big factors, but I think there's also some other features in LocalStack which we'll get to a bit later, which also are pretty powerful and even go beyond what the cloud providers can provide. So at least that's what we believe. So I think it goes even beyond, like having a local emulator allows you to do things like simulating certain scenarios or conditions, or persisting the entire state of the container and then moving it easily to some other container. And so, but I think, yeah, so convenience and quick experimentation, feedback cycles is one aspect, and then the other one is obviously some cost savings as well. All right, cool. That's great feedback. So what I'll look into, and I think we have just one or two more small samples here that we can step through, and then kind of wrap it up maybe with some questions at the end. So another interesting aspect is Streamlit applications. Again, this is more something that's built on top of the Snowflake APIs, but it's something that is being promoted quite a bit by Snowflake themselves. There's also a way to integrate these apps directly into the web UI, and it's very convenient way to just make data explorable and have interactive UIs and charts basically. And again, we just went ahead and used or taken some of these samples, Streamlit applications and ran them against the emulator. And I want to briefly showcase what that looks like. So as usual, I'll just go ahead and restart my container here. This time again with these trace logs enabled. I'll stop this previous sample. And I'll go into the Streamlit Snowpark Dynamic Filters directory here. And as before, we have a couple of make targets that we can run here. The first one is make init. That's just gonna initialize some test data. Let's take a look at what this actually does. If you go to Streamlit, I think there's a so if you go to the make file here. So init is actually running the SnowSQL, the SnowSQL command line interface with .assets setup SQL. And let's take a look at what's happening here. And this is essentially just running a bunch of create table or create database, create a table with some customer data in this case. So it's customer ID, years of tenure. This is actually also for a gym, like a gym setting with an average weekly workout count. So this is another data set. It's just a coincidence. It is also for a gym use case. And then, yeah, so we then insert a bunch of data into the actually with a randomization here. So this is using the random function from Snowflake to insert some random information. Is this a current customer? And so on, and it's using a generator with a row count of 10,000 in this case. You can also move that up to a higher number, but 10K entries in this case. So this has been created now, and then we can start the Streamlit application. And Streamlit is, maybe we can take a quick look at their website. If some of you may not be, oops, I think this was opening the wrong browser here. I was hoping to open it here. So this is on port 8501. Just gonna copy that in here. And this is the Streamlit application that is defined. Again, we just took that from one of the public samples that was already out there. And we can now use different dimensions here to explore this data. So we can say it should be a current customer, then tenure and weekly workouts are our dimensions or criteria. And then we can use this slider here to select a certain subset of the data. And then it's basically, or should be updating these charts on the fly. Let me see if I move this over here. See what's going on here. Is it actually running? Oh, so actually I need to hit submit here. So submit then runs the query again, and we can see it's actually, we're using one of these Sankey charts that is using the original data and then shows like a drill down using the filter current customer and filter tenure, and then weekly work results is what kind of the final result that we get here. So up here, we see the actual data frame, the actual table view, and then this is just this Sankey chart. This one is giving us a sequence of the statements. This is just for some description purposes here, but I think the main part is really this interactive chart that you can then interact with, which generally find these Streamlit apps pretty cool, pretty neat. There is a whole library of them. If you go to Streamlit.io, it's very easy to click together different components for creating maps, bar charts, and all sorts of different types of visualizations. And again, the nice thing is you just make a small change in the configuration, point them to the local endpoint, and that the functionality essentially works the same way out of the box. In fact, let's briefly look at the configuration itself. So where do we have so this is our chart helpers. I don't fully remember where the configuration was stored. Somewhere it needs to store our, oh yeah, I think it's in .streamlit, right? So .streamlit secrets.toml is the file where Streamlit just reads the the connection settings, and we just used the same hostname as before, and our test username and password, just as we did before. So yeah, again, a very easy way to just give somebody access to a repository, say you can spin this whole thing up, just give it a try, run 2 make targets, and you actually see the application running without having to do any pre-configuration in a real environment and in the real cloud. Okay, so that was Streamlit. Again, I think it's very much worthwhile looking into. Pretty nice framework for creating these data applications. And there's just 1 or 2 more points I'd love to touch upon, and then we can sort of wrap it up with some Q&A. So the first one is state management. So as briefly mentioned in the beginning, the state of LocalStack of the emulator is ephemeral by default. So if you start, you always end up with a fresh state. But we also have a way to persist the state as clearly there's a use case for that, being able to snapshot it. And there's 2 main ways that we support persistence. One is the regular intuitive way of persistence, where basically every interaction that you make with the system, every insert you do in a database basically results in a write, and everything gets persisted. And the other option is what we call cloud pods. And cloud pods it's basically a point-in-time snapshot where you can take a snapshot of the current state of the container, of the instance, store that to either a file or a server or to some storage backend, and then later on inject that same state back into the instance. So that's a very flexible way and mechanism to deal with state at any point in time and create these snapshots really of your instance. And I just want to briefly showcase what that looks like. Before we dive into that, just a short way how this usually works. So we have the LocalStack CLI, the command line interface, has this pod sub-command here. And then there's basically 2 main commands. One is called save and the other load. And you can just specify just some arbitrary name for your cloud pod here. This particular case here is using our managed storage backend. So if you run this save command, it actually stores it in a secure bucket that we host on our end. But there's also other ways to store these cloud pods, for example, in a local file. And what we can now do is we've prepared a small cloud pod ahead of time. So I'm just going to restart the instance here real quick, stop this demo app, and just copy and paste this command that we just saw in the slides. And it's doing this pod load command. And what's happening now is basically pulling that state from our platform storage. It's injecting it into the instance, and we now should be able to run a select from a table called test, which is contained in this cloud pod state. And we can then run a select, and it's giving us this output hello from LocalStack Snowflake. And we could do the same thing for any of the sample apps that we've created before. You can do a pod save, and then it's stored, and then later on pod load to load that state back into the instance, and everything is an exact copy of what you had before. And this is one of the more powerful features where we think that it's even going beyond what the real cloud provider is able to provide. Obviously, Snowflake has things like zero copy clones and also some very smart mechanisms to do copy of environments. But yeah, I mean, in our view, this is a very, very flexible way to actually deal with state and do also things like versioning over time. So there's some interesting use cases for cloud pods that we're more and more exploring, and we're also integrating this with Snowflake at this point here. All right, so I'm just looking at the time here. So I have maybe one last demo that's a bit more involved. It's basically running an entire dbt data transformation job with Airflow. So what's actually happening is it's using our Airflow MWAA, which is the managed workflow serviced by AWS, which we also support for the LocalStack AWS. So I could step through this, and what we would see in the end is basically a view of Airflow running the dbt transformation end to end. I'm very happy to do it. Just want to make sure that we are making the best use of our time. And if I'm looking at the time here right now, maybe it's actually better to move on to some wrap-up slides and then Q&A. But this is also available as a public GitHub in the public GitHub repository. In our samples repo here, if you go to Airflow dbt transformation, there's a couple of very detailed instructions on how to run this. And if you're interested, please feel free to give that a try. All right, so maybe just sharing one or two insights into like how, because you may ask yourself like how are we actually building this thing here. Just some very high level overview of what we're doing. So we have a implementation that's using currently Postgres as the main core engine. So we use Postgres to essentially store all the databases, tables, all the key data. And then we have a notion of what we call query processors. And those are pieces of logic that are responsible for doing some transformations on the queries, because it turns out that Snowflake and Postgres have fairly similar SQL syntax, but it's obviously not a one-to-one mapping. So we need to do a bunch of transpilation here. And then also some of the auxiliary services that we use, things like streams or stages that we showed before, or tasks, they are also just available as essentially services that are implemented in Python within the system. And obviously, if you're interested in getting more information, we actually put out a blog post a couple of months ago, if anyone's interested, which has a few more pieces of information in there, how we've built this. An initial implementation also used DuckDB as an alternative to Postgres, but we ended up going with Postgres for several reasons. It just turned out to be a better match for what we're doing here. And just to name one or two of the challenges that we're facing and have been facing and continue to face. So as mentioned, the syntaxes between Snowflake SQL and Postgres are pretty similar, but there are a lot of different subtle differences between the two. And one of the tools that we're using here is called SQL Cloud, and maybe some folks out there have heard about it or used it even before, which is a fantastic library. It's available open source. It's basically able to analyze the abstract syntax tree of a SQL query, and you can modify it basically and spit out some modified SQL. So it's a very powerful library that we're using for some of the functionality that we're implementing, and we were even able to contribute a few upstream PRs, and we really want to support this because it's a fantastic community project. And if you haven't heard about it before, I'd recommend you check it out and give it a try. Very, very interesting project there. And this enables us to do this transformation from Snowflake SQL to PostgreSQL and then sort of implement the functionality there. Some other challenges we're facing along the way, again, is more of an internal detail, but if anyone's interested, happy to also talk about this offline. We had to look into support for some Snowflake data types. For example, Snowflake supports a variant data type, which is a generic type that can take any runtime value like integers or varchars or anything else. And that does not exist as a concept in Postgres, at least not natively. So we had to come up with some extensions and ways to represent these variant types. So it's basically a small type system that we had to implement or have continued to implement in the emulator internally to support these generic types here. Yeah, there's one more interesting point. Again, I'm not sure we're gonna be able to dive much more into that, but it's one of the use cases that we are exploring, and we also learned about that in the AWS emulation space, is what we call hybrid scenarios. So basically ways to mix the local context with a remote execution, right? And one of the first POCs we built here is basically a proxy mode where you can run a request against the local emulator, but it actually forwards requests to certain tables or to all the queries to an upstream system, to the real Snowflake clouds. And we believe that this could enable some pretty interesting use cases where, for example, you could have something like a duplex mode where you run queries both against local and remote, like a local mirror situation almost, or even do things like a join over a local and a remote table, right? So not necessarily having to have all the information, all the data locally, but really being able to also join with some remote data. So it's still pretty early days, but we are experimenting a bit with these hybrid setups where part of the execution is happening on the local machine, but you're still integrating to a certain degree the data from a real Snowflake Cloud account. And again, I think in the interest of time, maybe we can follow up on that. If anyone's interested, happy to share more details after the meetup today in the upcoming days. Right. So I guess in terms of roadmap, so just and also to wrap up, so I think what we are seeing here is, as LocalStack, we're really sort of entering this LocalStack vNext phase where we're expanding our focus from this original use case of the AWS emulator to data pipelines and data platforms. Things are still very much in early stage. Direction looks pretty promising, and first and foremost, we would love to get your feedback. Work with early adopters to understand if something like that can be useful, where the maybe limitations are, and how we can improve this overall. It nicely integrates with our existing AWS services. So today we saw S3, right, where we store files in stages. We're also looking into things like Kinesis Firehose integration, for example, to do streaming from AWS into Snowflake. I didn't have a chance to demo the Airflow piece, but that's another very interesting sample app that we've built where everything runs locally. And again, I think we're more and more seeing these integrations between different cloud systems here. And also over time, what we are anticipating is maybe providing some value in the in advanced testing use cases, right? So if we think about test data management with the Cloud Pods use case that we saw before, you're giving you a way to very easily define, okay, this is my test data set, and I want to inject that into an instance, basically with one command, and it's up and running in a couple of seconds. And then really being able to use that as a mechanism for versioning and doing test data management for your data pipelines as well. And again, yeah, I hope that we can learn from you all and get some feedback. It's very, very early days, but if you want to get access to this early preview, then please reach out and let us know, and we're happy to work with you all. All right, I think that pretty much wraps it up. Kevin, over to you.
So I actually have a question. Does LocalStack actually allow us to change warehouses?
We have essentially, so when we talk about these emulators, we distinguish between just the mocking and actual emulation. So for warehouses, we really just you can switch between them, but there is no functional difference in that sense. So we're not doing things like this scaling of resource capacity and so on. So yes, you can do a create warehouse and use warehouse, but it has no functional implications in that sense. Yeah.
Okay.
Would you see an interesting use case there where you would want to maybe test some aspects of warehouses, or just curious if there's anything maybe we can look into?
It's mostly just around playing with what is the best way, especially for the streaming functions. I know I usually have to play with it a lot to get that one quite where I need it to be. And so especially if you can offload that to things like this, to be perfect. It would save so much money in testing.
Yeah. Yeah, absolutely. No, that's great. Great point. I've actually been at the Snowflake Summit a couple of months ago, and there were some interesting companies that are doing, I think, what you just mentioned, right? So certain warehouse optimizations and looking at usage patterns and maybe doing some routing of queries to different warehouses. So I think really what we want to get to with this solution is really like functional parity, like having the same functional behavior as the real system. Not really including some of the aspects of, one warehouse has higher CPU capacity, for example. So that's not something that we currently support. Oh.
Cool.
Okay.
Yeah, if anybody else has any questions or comments, please feel free to put them in the chat. I do want to remind everybody that in our upcoming days, we're going to actually have some other presentations. So on September 17th, remember there is Generative AI Foundations for DBAs with Warner Chaves. DBA Fundamentals, one of our favorites. We'll talk about all kinds of stuff that DBAs need to know about AI and how it can help you as well. And then on September 24th is Azure and SQL Server Disaster Recovery for Everyone with Marco Urbino. That one should be fun to talk more about disaster recovery, everyone's favorite topic, and especially when it hits, because if you don't know about disaster recovery, that is the time to know as much as you can, because if you don't, you'll know it real quick. So please feel free to put your questions out there if you have any. As always, Warner, this has been a great session. Actually learned a lot about LocalStack, so probably I know I'll have some follow-up questions for you, especially about the remote versus local. That wouldn't sound like a fun thing to play with and look at. Yeah,
100%. Absolutely. Yeah, if I just can maybe drop one or two more links here. So this is our Snowflake LocalStack Cloud, our getting started guide for the preview. And also, if someone is interested in joining our Slack community, we have a fairly active Slack. If you want to get involved in some of the discussions, that would be the link here: LocalStack Cloud/Slack. Just as a 2 pointers here.
Awesome. Well, it looks like no one has any questions, but if you do, please feel free to, as Waldemar said, put it into the Slack channel or email and all kinds of things to get a hold of Waldemar and ask all kinds of questions. So with that, thank you all very much. Have a great day, and we will talk to you all soon.
Thank you. Thanks so much for having me. Bye all.
My pleasure.